Here it will have uniform speed. How do we can write total time? Okay, I think I'll write T only. This will be 2dV. Straight away you can write it. Then half of the time period of oscillation of it, pi m by k plus pi m by k. So total it will be 2d by v. No, is it SHM? No question. This is SHM, but this is uniform velocity motion. This is SHM. This is a uniform velocity motion. Okay, simple idea-based problem. For only half of this, it will be in contact here. Again, the spring will be compressed. Again, it will come back. Once it reaches here, it will lose contact with the spring. So in this region, the block will not be in contact with the spring. Here you can see that one. So it will go and compress. Then once spring comes natural length, it will lose contact here. Okay, let's have one more thing like regarding the SHM. So we ended up equation like this, no? F equal to minus. Okay, let me write this equation. If n equal to 1, it will be SHM. What is F? F is a restoring force. If n equal to 3, 5, 7, 9, it will be oscillatory. Simple. Then if n equal to 3, 7, 5, 9, it will be oscillatory motion. If n equal to even, select 2, 4, 6, 8. I think n is even, no? Is n is odd. If n is even, it will be rectilinear motion. Able to understand now? So when a force acting on a system, if it is of like this, no, so then it will be, so we can categorize whether it's a SHM, oscillatory, this one. All oscillatory need not be SHM, but all SHM must be oscillatory. Am I right? All SHM will be oscillatory, but all oscillatory need not be SHM according to this condition. So what is the meaning of this is like, so if you have okay, if the force is proportional to negative of displacement, it will be SHM. I think it's very simple. If I displace body slightly from equilibrium, what do you mean equilibrium? Net force should be 0 at x equal to the equilibrium. I slightly displace it. How the displacement given? Towards right, force negative. So the body will experience force towards left. If you give displacement towards left, the force will act on towards right. So it will bring it back to equilibrium. This is what the stable equilibrium. Able to understand? If it is like this. So even according to this one, F equal to minus K x cube is there. If it is a curve, it will not be SHM. It will be oscillatory. So instead, so this is SHM, condition for SHM. Now if the curve is like this, so it is not a some curve. Let me show it. You see, it's not a linear. No, this will be oscillatory, but not SHM. So what happens if the curve is like this? So you may get graphical problems like this also. If the curve is like this, is it SHM? Anybody? Will it be SHM? You displace body towards right. You displace body, straight line passing through origin. No, you displace body towards right. How the force will act in the direction of displacement. So unstable equilibrium, so rectilinear motion will act here. You displace body towards left, the force will act towards left. F negative means towards left. So therefore, what is this? Rectilinear. Don't say straight line. So you have to look at the force acting on a body. If it is satisfy this graph or satisfy this equation F equal to minus kx, it's SHM. If it is like this, it's not SHM, but will be oscillatory. If it is like this, then it'll be rectilinear motion, no question of it. So this will be unstable equilibrium. Here it will be stable equilibrium. So when the body will execute SHM about stable equilibrium or about unstable equilibrium, about stable equilibrium position. Fine. So therefore, I'll write it. A body executes SHM about stable equilibrium position. Here, a body oscillates about stable equilibrium position. Fine. What about rectilinear motion? If the body is in unstable equilibrium and if slightly displaced, the force will act in the direction of displacement. It will be rectilinear motion. So I think this is very important for us. So will it execute SHM or not? How to determine? Just check, is it in stable equilibrium? There's one more method for us, which is going to help us a lot. Coming numericals. There's one just like some mathematical treatment, graphical or any other thing. There's a method what we can apply it. I think now you know spring block system, some little bit about trigonometry, kinematics of SHM. Okay, try to work out problems related to this week's syllabus only. Don't take like a fluid mechanics SHM, rolling SHM, because your schedule is only spring block system and kinematics of SHM, energy, graphical problems. Applications will go, simple pendulum, compound pendulum, rigid body oscillation, they will come next week. Okay, this I think I have a lot of questions. Tomorrow